All right, so we're gonna go to our notes. Would you guys open up last class, we were working on, let me go to my 490 notes. And this one that says logs, and we were talking about exponential growth and decay. For you guys that are at home, I'm gonna walk away from my computer. So if you are having difficulty hearing me, please just let me know. And I can, of course, come back, or I have a microphone that I can set up for that. But I just want to make sure that everybody, you guys back over there in the corner, you guys are good. You can hear me all right? Okay. Okay. I assume you guys are all right there. Okay. So we were talking about exponential growth and decay. We had this, this equation, y equals AB to the X. And that was a big one where, Y was our final amount. A was our initial amount. B was like our growth rate or decay. And then X was time, typically. So today we're going to do a similar thing, but we're going to be talking about a little bit more specific in terms of things are going to grow, but we're going to see how long it takes to grow, to double something. Okay, so it's called the doubling time, or how long to have half of something, sometimes referred to as half-life in a lot of different areas, but there's what's called the halving formula. So this, I'm going to scroll down, and you guys probably should write down. So the first thing we're going to talk about is the halving formula. Okay, and that really just means taking half of something. And it's essentially the exact same formula, but it's not going to look the same necessarily. So the halving formula is y equals a times 1/2 to the t over h. And a lot of those things mean the same thing that they did before. Y is still the final amount. A is the initial amount. Now, 1/2, of course, is a number. We don't need to define that, but where that really comes from, if you look back in our other formula that was a b to the x, like that b value, if you took 1 minus half of something, or 1 minus 50%, you would get 0.5, which is 1/2. So that's where this 1/2 comes from. It's just 1 minus 1/2. And since we use the halving formula kind of specifically for certain problems, this has its own special formula, but it's just kind of a derivation of the other one. T is time still. And H is the halving time. So we may use, here would be an example of when we might use this. Let's say you buy a car for $18,000. How about a new car is $18,000? Okay, which might be about right. And depreciates. Remember, we said that depreciated means it goes down in value, which almost all cars do as soon as you drive off the lot. And depreciates to half its value. Every 4 years. Okay, so I'm gonna add on to that in just a second, but just let me explain what that does not mean. So you got a car, it's $18,000. Every 4 years it depreciates to half its value. So after 4 years, it's worth $9 grand. But it doesn't mean then after 8 years it's worth 0. Okay, after 8 years, it then would be half of 9 grand. And then after 4 more years, it'd be half of 4,500 and so on and so on. Okay. All right. So we want to know what is its value in 17 years? So as long as we know our having formula here, we want to know our final amount. Why? We have our initial amount, which was 18,000. Times 1/2. And our exponent now, our time is 17 over the halving time, which is 4. And that part kind of gets some students because sometimes it doesn't really make sense to students. Why are we dividing by 4? But really what the reason is because we're taking this amount of time, 17 years, and it's going to take half its value every 4 years. So it's going to go through like a little more than 4 half-lives, so to speak, 17 over 4, 4.25 half-lives. So we're just going to plug this into our calculator. All right, so let's do that. If you guys have handheld, that's fine. You can take that out, or I will go to, where is my calculator? All right, so here we go. We had $18,000 times 1/2 to the, and that was 17 over 4, I believe, right? So remember when you use the app, I'm going to click and hold the enter. Okay, but it's worth $946.01. Don't forget to round. This is money, right? So we want to round it like money. So $946.01. All right. Any questions? We okay? No. Okay. All right. Let me. I think you guys got that. I was going to do another example, but I think you guys got that. Let's then go to. There's also, instead of a having formula, a doubling formula, which is very similar. And people are always fascinated with doubling. Like, how long is it going to take me to double my money? You know, that's always a big question. And the doubling formula is similar. So it's y equals a times 2 to the t over d. So again, y is the final and a is the initial. I'm not going to write that down again because it's been consistent. So all them, t is still time. The only difference is d is the doubling time. All right, so let's say, for example, let's say we have 2,200 bacteria in a petri dish. So 2,200 bacteria in a petri dish, and they double every 10 hours. So how many How many bacteria are in the dish in 40 hours? All right, so we know it's a doubling problem. So we want to find our final amount. Given our initial amount, which was 2,200 times 2 to the 10 over, what was the, oh, I'm sorry, 40 over 10, not 10 over 40. 40 is the time and 10 is the doubling time. So I'll go to my calculator. 2,200 times 2. The 40 over 10, which of course you could write to the fourth, but just to show you the steps here. All right, so 35,200. Hopefully it's a big Petri dish. All right, we good? Yes? All right, and then, you know, if you think about this one, and I kind of gave it nice numbers, but without knowing this doubling formula, this particular one, remember we started with 2,200, and then after 4 hours, it's going to double, right? It's going to be 4,400. And then after 4 more hours, it would double again. 8,800. After 4 more hours, that would be what, 17,600. And then after 4 more hours, it's going to double that. That's going to be 35,200. That's the same thing we got after 20 hours. Okay, so just to show you that the math works out. And notice that we went through 4 of those doubling times. That's what this is all about here, okay, in terms of the formula. All right, well, and just to give you a little glimpse, what if I changed the question? I said, well, how long is it going to take for us to have 100,000 of these things? You know, so now we're solving for time, right? So now we want to know, like 100,000. I got my 0. Yeah, 100,000 equals 2,200 times 2 to the, now we're trying to solve for t over 4. Any ideas on how we might solve for that? Got to solve that for t. Any idea? Come on, you people at home, feel free to chime in. Anybody? That was the same. I'm referring to the same problem. So that was oh, I'm sorry, you're right. It should be 10. The doubling time is 10. Thank you very much. My mistake. The doubling time is 10. Thank you. So I'm trying to figure out how to solve that for t. No ideas how we get t by itself? Come on, throw something out there. You guys are algebra wizards. What's that? That you're on the right track. Okay, we could take both sides. Somebody said multiply by 10. We're not quite there yet. I mean, because we got to get, this is a problem, right? So we got to get rid of that. Now we could take it to the 10th power. Okay, but before we do that, see, the problem is that we have all of this stuff together here. So we first, I think, would need to get rid of this 2,200. So we could divide both sides by 2,200. And so now we have, well, let's see, what's that going to be? 1,000 divided by 22. All right, come on, calculator people. What's 1,000 divided by 22? Help me out here. 45.45 repeating?
Yeah.
It's a weird number, isn't it? Okay, thank you. All right, now we're still in this kind of pickle here that we've got 2 to the t over 10. Now I could get rid of that 10 by taking both sides to the 10th power. Because remember, when you have power to a power, you multiply the exponents. I still have 2 to the t equals 45.45 to the 10th. How do I get that t down from being that exponent? All right, well, I'm going to let you hang on that one then. Unless anybody thinks they got it. Oh, I heard somebody say log.
Somebody wrote in the chat.
Oh, somebody wrote in the chat. Who is that? I'm so happy that somebody wrote that in the chat. Yes, very good. So there you go, logs. All right, thank you for pointing that out. I missed it. Yeah, we could put it in log form. Remember on the Kahoots, like, how do you move this into log form? Well, the 2 then becomes the base. We would have log base 2 of 45.45 repeating to the 10th power. Now that is one ugly number, but that's why they make calculators, right? So then we could just plug that thing right into your calculator. That will solve for time. So that's the whole idea of why we need to be able to go back and forth between log form and exponential form. So nice little preview into where we're headed in connection with the doubling time and half-life time. All right, great job, everybody. Any questions on that? You're good? Yes. Yep. Here?
Yeah.
Okay. So the question was, what's the result? So this, we would then plug into our calculator. Okay, so as an approximate, I could do, where is my log button? There we go. Log base 2 of 45.45, and I know that was repeating. And I'm going to write that to the 10th. Whoops, that's not how I want to do it. All right, how do I get that to the 10th? Oh, I don't think it's going to let me. I think I'm going to have to put that 10 out in front, and I'm getting into the next lesson then. Well, yeah, but I need to just if I write it right now to the 10th, it's going to do the log stuff first and then do the 10th power, but that's not necessarily what I mean. I want to do the 45.45 repeating to the 10th and then take log base 2 of that. Okay, and it actually, this calculator is not going to allow me to do that. There's a method that we use. We actually take the 10 and write it out front. So we would write 10 log base 2 of 45. And so that would be our time. That's how long it takes for 100,000 to be in the Petri dish. Okay, sorry, we got way ahead of ourselves on that last step there. So, but I'm glad you asked. Thank you. Any other questions from you guys out there?